Hello, I am Abhinav Sharma. Welcome to Python Wife.
So in mathematics, the factorial of a number is the product of all the integers from 1 to that number. The factorial of a numbers 1 and 0 is 1 itself, and the factorial for the negative numbers or the floating numbers are not defined. So for example, if we need to find the factorial of 4, so it will be 4 into 3 into 2 into 1. Similarly, we need to find the factorial of 5. It will be 5 into 4 into 3 into 2 into 1. And the factorial of 1 and the factorial of 0 is equal to 1. And there is no factorial defined for the negative numbers as well as the floating or the decimal numbers. So before writing the recursive function for our factorial, let us mathematically define the equation. So let's say similarly we need to find the factorial of an n number n. So what it will be? It will be n into n minus 1 into n minus 2, and this will go up to 1. You all agree with me? Similarly, the factorial of n minus 1 will be similar to this, right? This will be the factorial of n minus 1 numbers. We will also need n minus 1 here. So can you observe a pattern from here? If we are needed n numbers, the factorial will be from n, n minus 1, n minus 2 up to 1. If we need factorial from n minus 1 numbers, you can see here we need factorial from n minus 1, n minus 2 into n into up to 1. So what equation we derive from both the above equations? So the simpler equation will be factorial of n can also be written as n into factorial of n minus 1. So with this equation, you can simply observe a pattern of recursion. Okay. So let us also understand what can be our base condition. So what will be the base condition? Base condition will be, we know the fact that the factorial of 1 and 0 is 1. So the base condition will be the 1. Another, what can be the second condition is what can be the recursive case or the recursive function. So n into factorial of n minus 1 will be our recursive function. Third, in unintentional cases. So what are our unintentional cases? We already discussed that negative numbers or the floating numbers are not defined as a factorial. So this will be our unintentional cases. So by keeping these three things in mind, three conditions in mind, let us create a function which will find the factorial of a number n. Let us create a function called let us keep a complete name instead, factorial, all right? And in this function will take an argument n. Now first let's write our base condition. So what will be the base condition? If n is equals to 1 or n is equals to 0, we will return 1. All right. Second, let us write our unintentional cases. So if n is less than 0 or int of n is not equal to n, which means if the integer value of n is not equals to our n, if n is floating number or a decimal or a double or a complex number, this will return false. And if that case happens, we will again return 1 or we will return not defined. All right. Now let us write our recursive function. What will be the recursive function? So the recursive function will be return of n into factorial of n minus 1. So this will be altogether creates a function which will find a factorial of a number. Now let us try to find a factorial of a number 4. All right. So we discussed earlier that the factorial of 4 will be 4 into 3 into 2 into 1. So now let us visualize this thing before running it into our final execution. So from this diagram, we will understand the step-by-step process of a recursion. So here you can see we need to find the factorial of a number 4. So when 4 goes into n, it will check first if it is an unintentional case. If 4 is lesser than 0, no. If 4 is a fractional or a rational or a decimal number, no. So it means it is not an unintentional case. Then it will check, is it a base case? No. 4 is neither a 1 or 0. So finally we will walk through our final condition, which is n into factorial of n minus 1, which will split it accordingly 4 into factorial of 4 minus 1, which is 3. So the function control will go to this one. Here you can see it will again check for base condition as well as unintentional case, and 3 is neither of them. So it will again goes to the last case, which is 3 into factorial of 3 minus 1, that is 2. And then again the function will go to the last recursive call again, and it will again check for the base condition. Here you can see if 2 is an unintentional case or our base case, no. So it will go to the last statement, which says 2 into factorial of 2 minus 1. So here you can see a base case is achieved at the last recursive call, which makes factorial of 1. And we know that the factorial of 1 is 1 itself. So from here we will go back, our control will go to the second recursive call. And here you can see we have achieved the result, which is 2. So from here 2 is returned, and then our control will move from this function to our before factorial function stored in the stack. Inside this function 3 into factorial of 2 was asked. Factorial of 2 is 2. So 3 into 2 is, which means 6 is returned. 6 is returned to the factorial function above it, is stored in the stack. So here it will ask for 4 into factorial of 3, and factorial of 3 is 6. So 4 into 6 is 24. So final answer is returned in here, which is 24. Now let us run this code into our terminal and let us check if the result satisfied or not. So let us print this factorial function, and here let us run this Python file again. So you can see same output is achieved, which is 24. And it makes clear that the recursion is happening correctly. Let us check for the base cases as well, which is 1. So what happens if I run 1? It will return 1 simply because at base condition we will return 1. What if any other value is given? Let's say -1 is given. And it says if n is less than 0, it will return not defined. So our factorial function is working perfectly.
Thank you for watching. For more such videos and detailed explanation, visit pythonwife.com.